If you have any sort of time series data, whether that's IoT readings or performance metrics or any sort of heartbeat system that you're storing the data in MySQL, I'm going to show you how we can operate on the time series data and chunk it down into buckets and run mins and averages and maxes over all of that data in a really flexible way. But before we do that, I have to tell you, MySQL is not specifically built for time series data. So I would use this until it becomes too much, and then I would look for a specific solution. I'm a fan of never optimizing before you need to. And honestly, MySQL can take you a super long way. And so I'll show you how it's done here. But if you bump up into the limits of what you can do with MySQL, you might look at a specialized time series database. Let me show you the data set that we're working with here. So if I do select star from time series, limit 10, you'll see we have a very basic setup. We've got key, value, and the time at which the thing happened. The domain that we're working with here is basically, we're taking a snapshot of how many jobs are on the high queue, the low queue, and the CPU of our two different web servers. So we're basically monitoring some performance metrics of our web application. Every 5 seconds, we take a little look and we insert a new row. So every 5 seconds, we're inserting 4 rows because we do have 4 metrics. The problem is when it comes time to graph this or put this on a chart, we may be pulling back thousands or tens of thousands of rows and just throwing it at this chart. And it's not going to look very good, and it probably won't work. So here's what we're going to do instead. We're going to take all of the data points. Let's say we're generating a 6-hour chart. So we have 6 hours times 60 minutes times 12 data points per minute. So that comes out to be 4,320 data points for this 6-hour chart. That is just way too many. Let's say we want to compress that down into 60 data points that accurately represents this data. To accurately divide this data up, we're going to chunk it based on time. So 6 hours times 60 minutes times 60 seconds is 21,600 seconds. That's the entire number of seconds for this timeline that we're looking at. If we want to divide this into 60 even chunks for our chart, we divide it back by 60, and we see that the chunks are 360 seconds long each. So every bucket is going to span the duration of 360 seconds, and when you add it all up, that spans the duration of 6 hours. Inside of each bucket, we're going to take all of the data and compress it down into one value that we'll then feed onto the chart. So if we extract this into a general formula, you get the duration of the chart in seconds over the number of data points that you want to show on the chart, and the resulting value is how many seconds long each bucket should be. We can check my math here, and we have 6 hours times 60 minutes times 60 seconds divided by 60 data points, and we do get that 360. So now we need to start talking about how do we chunk our time series data that's actually in the table. I can show you a way. So if we do select star from time series, and let's just say we want where the key equals Q high. Let's just work with one single metric for now. And so if we do that, we're going to get, it's got 200,000 rows in there. So we have a good working set of data. Now what we're going to do is we're going to take this date time column, we're going to convert it into a time stamp, and then we're going to use our seconds per bucket and that timestamp column to figure out what bucket each of these rows belongs in. Let's just start immediately by converting this date time into a timestamp. So this is going to make it a little bit easier to work with because we're going to be treating it as an integer. So we can just pass the date time column into this timestamp function, and it gives us back a big integer that is the Unix epoch. So you can see 0 seconds, 5 seconds, 10 seconds. So this is just seconds from the epoch, and we'll change this to as TS so that we remember. And now we're going to take this timestamp and we're going to divide it by the number of seconds per bucket. So if we take this, we'll duplicate it so we can keep the old guy around, and we say divided by, and we're doing a 6-hour chart at 60 minutes per hour at 60 seconds per hour, and we've decided we want 60 points on the chart. You could very easily change this to 100 points on the chart or to whatever you want. We're going to keep it at 60, and now if we run this, you'll see, okay, I don't really know what that tells me, right? I see this float, and it looks like these all end in 40, and then way down here, it changes to 41. So it changes to 41, but interestingly, it changes to 41 at the 6-minute mark. And how long is 360 seconds? 6 minutes. So our bucketing is working correctly. Let me see if we can make this more clear. If we can move that down, we'll take a floor of the Unix timestamp. So we're just going to drop off any of the remainder, and we're just going to call this as bucket. Now, if we run that, the bucket number has really no semantic value. There's nothing special about bucket number 340. It's just going to be used as a way to group these items together. So in our setup here, all of these 340s are going to be grouped together and compressed into a single number that is then represented on the chart. So now we know what bucket each row belongs to, right? And we can change the chart duration or the number of data points, and the buckets just automatically update, which is kind of nice. But now we need to start processing on a bucket by bucket basis and compressing all of the rows in a single bucket down to a single data point, which is how we go from 4,300 data points down to 60 data points, which is what we're looking for. To do this, we're going to use something called a window function in MySQL. At the time of recording, Vitess does not support window functions, and PlanetScale is built on top of Vitess, and so we don't support window functions yet either, but plain old vanilla MySQL does, and at some point in the future, Vitess will as well. And so I'm going to show you how to do this, but if you try this on your PlanetScale database, you might be a little bit disappointed, but stay tuned for when we support window functions. Let me show you a window function. They're kind of wild. It basically lets you compute aggregate values on a row by row basis as you're scrolling through the data set. What does that even mean? So if we select key value and we have the timestamp and the bucket, that seems good enough for now. Then what we can do is we can say count star, but instead of count star over the entire result set, we can pass through a window. So we can say over and then tell MySQL, hey, here is what I want you to define as the working window, the working group, or the working bucket for this count star. So what we're going to say is we're going to say count star over partition by, and we're actually just going to copy this and take our little bucket guy, drop it in there, and we're going to say within the window, order by, and we can just use the date time because it's the same as the timestamp. And so if we run this, you'll see something kind of wild here. You'll see it's a very long name, but if we shrink that down, as we scroll through, you see that this count is just going up and up and up. So what this tells me is this is processing on a rolling basis. This isn't counting over the entire window. It's counting as it's going. So it's saying, all right, for row 1, the count of this window is 1. Now I'm on row 2. Oh, actually, I know now that there are 2 rows in here. Row 3, well, I know that there are 3. So it's doing the counting on a row by row basis. And if we scroll all the way down to where the bucket changes, we get the interesting bit of information. Because we told MySQL, hey, partition by this made up thing that you and I are calling bucket, when it reaches a new bucket, all those aggregations, they just start over. It says, great, you told me to partition by this thing and count over it. I'm in a new thing now. And so I'm going to start the count over, which is pretty, it's pretty cool, right? I think so, but I think a lot of this stuff is cool. We're calculating rolling aggregates over a part of a result set without losing the intermediate data. Honestly, how is that not cool? Let's use that instead of counting. Let's do averages and maxes and mins and that kind of stuff. We could just copy this guy and come up here and put that in there and change this from count to average. And what we're averaging is actually the value, not everything. And let's give this a name of average, and we'll give this guy a name of count, and we could run that and it would work. So we're starting to see kind of a rolling average here. You see the first value is exactly equal. The second average is the average of 97 and 95, which is 96. And so this rolling average just keeps going, just like the count just kept counting up. However, this is a little bit gnarly, right? Having to redefine that window in line. Well, we don't have to do that. We can say window bucket as, and then we can drop this guy down here. And so we're defining a named window. And then instead of over that, we can just say over bucket. And now if we run that, that works, which means we can factor this out. And now we're only calculating that window once. So this is a good quality of life thing, but this is also a performance improvement because MySQL knows, hey, this is all the same window. Do this work in the same window. Let's keep cruising right along. We have a lot of data we don't need because we are ending up with all of this intermediate data in here. But what we really want is kind of just the end. It's kind of the last row. We're going to fix that in a second. Stay tuned for more. So if we do max, min, that's probably good enough. There are some more window functions you could look up. There's like standard deviation and variance and that kind of stuff. I don't really know too much about that, so we're gonna move on. So if we run this, now we're starting to get all of the things that you might wanna put on the chart. So maybe CPU, you don't wanna put the max because sometimes it peaks out at 100 and you wanna put the average. Maybe the queue worker, you wanna put the max and you don't wanna put the average because the max really matters. We're just gonna calculate them all just for fun. Now the question is, what do we do with all these intermediate rows? I don't care about those rows. I'm trying to get down to 1 row per bucket. Glad you asked. Let us use this function here. So we're gonna use a function called lead. We're gonna use a function called lead and we're gonna say, I wanna look at the next key. I wanna look at 1 key forward. So MySQL has a lead and a lag function. And what that allows you to do is while you're operating on a single row within the window, you can say, hey, just peek down 1 row and grab that value. Give me the next value and let's pull that back up to my row. It only works in your partition. So if you peek outside of your partition, you get a null. So we'll say as next k, and if we run that, we see we have a problem. I didn't put the window. Whew. Next lead over bucket as the next key. So you see all the next keys are Q high because we actually are selected down to Q high only, but the only thing that matters is that when you reach the end of a partition, it cannot peek beyond the partition, which means you're left with a null, which means you are at partition's end. So we're gonna use that to our advantage. Case when lead over bucket is null, then 1 else 0, and we'll say final row. And I've done it again, haven't I? End, forgot the end. There we go. Whew. All right, so all of these are final row 0 until we get down to here. That is our final row. That's all of the data, min, maxed, averaged, counted, and compressed into a single row. Now, how do we get just that row? Well, we can take this and we can turn this into a CTE. So we can say with windowed, we can name this whatever we want. I'm just gonna call it windowed data as, and we're gonna take this guy and wrap it in an entire set of parentheses here. And from down here, we'll say select star from windowed data where final row equals 1. And that's gonna take a second because we're running over 180,000 rows. And there you go. There is your single row per bucket with the value computed such that you can decide if you want an average or a max or a min or for whatever reason, the count. You see that it is evenly distributed. We have 72 items per bucket, and that's because those beats are so regular, and so those buckets are all equally filled. There's one other thing that we can do up here. If we did, for whatever reason, want to pull the start time of this bucket, the end time is basically encoded here in this timestamp because this is the final row and this is the timestamp off of the final row. But what we can do is we can say first value of, we'll just copy this. So we'll say first value of the timestamp, and we'll change this to last timestamp and first timestamp. And we need to put the window here again, first value over bucket as first timestamp. And if we let that run, we'll speed this up in a second with some indexes. We don't have any indexes at all, but you can see we have the first timestamp and the last timestamp. And that might be helpful when you're shipping it out to your front end or your charting library or whatever to know where should I put this on the chart. You can decide if it's first or last, it doesn't really matter, but at least you know what duration this data point encompasses. Up until now, we've only been partitioning by the bucket that we generated, and that's been okay because we've been scoping the query down to only a single key. we are going to open that scope up, which means we need to partition by two things because we want to calculate metrics over a bucket, yes, but for an individual key. We don't want to calculate the Q high and Q low metrics all in together. We need those to be separate, which good news is you can partition by more than one thing. So let's do that. We're going to drop out Q high, and we're just going to add in, just for now, where date is greater than cur date, greater than or equal to cur date. Let's do that. Let's see how that works. Okay, so we don't get any errors there. We're going to get really bad data. This is going to be super wrong. So let me show you how we can fix that. So instead of saying partition by floor, we are going to keep that, but we're going to partition by the key as well as the floor. And then we're going to order by the key and then the date, because we want all of the keys to be together with their dates and the next set of keys to be together with their dates, rather than all the dates being together with the keys being interspersed. So now if we do that, we should see, again, this is going to take a long time. We will fix that. We should see the key is Q high, and we're going to see a bunch of those, and then we can go all the way down, and then we'll see the Q low starts. And so this is a good way to do it if you're calculating a rollup table or a result set across many metrics at the same time. This is a totally valid way to do that. If you're only going to do it across one metric at a time, I would restrict this inner query up here. I would restrict this inner query on key instead of partitioning by key and then coming down here and restricting on and key equals, because you don't want to do all the rollup work. You don't want to do this window work if you're just going to throw it away at the end. But this is the way that you would calculate it across multiple metrics. Let's see if we can speed this up. Right now it's taking 8 to 10 seconds for a 6-hour chart, and that's just going to be too long, especially when we start hitting like 7 days. So we're gonna look at an index, but then we're also going to talk about a rollup strategy. Honestly, the best thing that we can do is probably only calculate or only pull the data that we're actually looking for. So if we change this from current date to now minus interval of 6 hours. Let's change this to 7 just to make sure that we encompass the entirety of the bucket. So if we run that, you'll see we are going to get it hopefully a little bit faster. So it is a little bit faster. And then if we alter table time series, add index, and let's add an index called date and key value, and we'll put that over date and key and value. And so if we run that and then we run this back, you'll see, honestly, it doesn't make too much of a difference, at least on this data set, but it will be able to use this date to help eliminate some data here. So as the data grows, this may become more valuable. Here's the problem though. The problem is, honestly, this is about as good as it can get. And if you change this from 6 hours to 24 hours and 7 days, it's just not gonna run super fast, to be honest with you. So here is what I would recommend instead. I would recommend taking these values and rolling them up into a summary table. Summary tables will be a video all into themselves, so stay tuned. But the basic premise behind a summary table is you take a computation that is expensive over a huge amount of data, you run it once, and you store the result in a secondary table. So a roll-up table, a summary table, an aggregate table, something like that. And then after that, you're only calculating the difference. So in our case, we would take all of the buckets and we would calculate the values for those buckets. And then at runtime, we would only calculate the last remaining bucket that is left open. So we're only going to be calculating over a very small set of rows instead of over potentially hundreds of thousands of rows at runtime, which frankly is not going to work super well. I'll leave some of the detail as an exercise for the next video, but I do want to get you started on the right path. So let's drop out the value there, and we're just going to make up a key, and we'll say 6 hour, 60 points. That's probably good enough, and we'll call this the type. And so if we select that, we're going to switch first and last around because that's been annoying me. And there's the bucket, over bucket, there we go. So all of that. Now, if we run that, we see we have this as our output. And now what we can do here, we can actually drop off final row. We don't actually need to see that, but that's fine. What we can do here is we can say insert into time series, you want to call it rollup, time series rollup, select star from windowed data. We'd probably just We probably wouldn't select final because that's kind of annoying that it's there. And this would then become the query that feeds our rollup data table. We would have to do some stuff around unique indexes. We'd probably put a unique index over the type and the key and the bucket would be my guess. We'd put a compound index over type, key, and bucket. Anytime there's a collision, we would update the values, which means all of these values over here would be continually updated in that rollup table if the bucket hasn't closed yet. And then we could select directly from the rollup table instead of trying to calculate this at runtime. So then you would run this in the background, and once it's populated, you could drop this down to, I don't know, 15 minutes, because all of the historic buckets are not going to change. Only the most recent bucket is going to change. This is the most complicated one we've ever done on this channel, and I don't know, I love it. I think it's so fun. We will do a summary/rollup/aggregation table later, but first we need to thank Steve, the editor, for putting the team on his back on this video with the graphics. So thanks, Steve, and please subscribe. We'll see you next time. See ya.